Hello, my name is Mr. Arnapol, and today I'll be teaching you your last year of dosage calculation questions. So these are all your rounding rules that you've been using. Make sure you review these. I've also added in the heparin rounding rule from last semester that we added in. We're just going to jump right into it because at this point you've been taught most everything, including how to convert. So we're just going to show you how we can ask you these questions at this point. So, ordering 250 milligrams IM now. You've been given 1 gram per 3 ml vial. How many milliliters do you need? So like we've done in all the other questions, you start with the X. So I need mils, so X mLs equals what? Well, I have the arrows and I have the boxes to help you walk through this. What do I have up here to help me with this? X mLs, we have 1 gram per 3 mLs, so I can attach that. 3 mLs per 1 gram. Okay, so I have the mLs there, but I need to cancel the grams. Do I have anything? Well, I have milligrams, but that's not grams, which means I need to convert this. I'm going to add my gold lettering. Remember, the gold lettering is always your conversions. You just need to know. Begin inputting what you must cancel from left to right. So I have grams. This way I can cancel that gram with that gram, leaving me with mLs over milligrams. But I need to get rid of milligrams because all I want is mils. So I'll pull this and bring it down here. So I have the milligrams here and the milligrams up here, allowing me to cancel. All I have left on the right side of the equation is milliliters. So I'm done adding things to this equation. So I say multiply and divide across to give me 0.75 mLs. Gotta have a little red cloud to make sure I've got the right answer. And to see it down there, once you've removed everything, all you have are, this is what it would look like when you do this, once you remove all those suffixes. You have on hand hydromorphone, 4 milligrams per mil. You need to administer 0.015 milligrams per kilogram to a patient who weighs 150 pounds. How many mils should you administer? Looking at this, I can already tell there's going to be some conversions we need to do. So how many mils? So I have to start with the mils. X mLs. So what do I have up here? 4 milligrams per milliliter. 1 milliliter over 4 milligrams, like we said. I need to get rid of the milligrams. Do I have anything up here with milligrams? I do. 0.015 milligrams per kilogram. So I'll put it up there. Same exact way. I need to be able to cancel out the milligrams, which I do. Now I have kilograms on the bottom. What do I have up there? Well, I don't really have anything, but I do have pounds. So I know I need to convert. So I'm going to cancel out the kilograms. And I have mils on top, pounds on the bottom. Well, I need to get rid of pounds because all I need is mils on top. So I put the 150 pounds up top. Canceling those out. Do I have anything left up there? I do not. All I have is mils, which tells me all of my suffixes have been canceled but the milliliters, so I can go forward and get the answer. Multiply across and divide, giving me 0.26 mils. You once again, gotta have the red circle. Gotta have it. Dopamine is ordered at 3 micrograms per kilogram per minute. The patient weighs 74 kilograms. The medication is available in a mixture of 800 milligrams in a 250 ml bag. What would you set your pump to in mils per hour? Okay, well, I need mils per hour, right? So X ml per hour. You did this on last semester's notes, and also we have several other practice ones. But it's the same idea. What do I have up here with mils per hour? I don't really have anything with mils per hour, right? But I do have mils, so I have 250 mils in an 800 ml bag, 250 milliliters in an 800 milligram bag. So I need to keep this, and I need to get hours on the bottom. So what do? I need to cancel the milligrams. How do I do that? There's nothing up top to deal with that anymore, but I do see micrograms. So I need to convert. I need to get rid of the milligrams and get down to micrograms so it matches. Now I have micrograms on the bottom. Once again, I don't need micrograms on the bottom, I need hours. So I need to pull across the micrograms here, which is kilogram per minute. So 3 micrograms per kilogram per minute. That allows me to cancel the micrograms. Now I have kilograms per minute. I'm getting somewhere, but I still have more things to cancel. So I say, okay, what do I have to cancel? Well, I do have kilograms here. So I need to cancel out the kilograms. Now I have 250 mils on top, and I have minutes on the bottom. I need to get those minutes to hours. Once again, conversion factor you just need to know, 60 minutes in an hour. That allows me to cancel the minutes out. Now all I have up there after all these calculations is mils and hours. I needed mils per hours. I know I'm done. So I get to multiply, cross, and divide. And that's what it would look like. To 4 mils an hour. 4.1625 becomes 4 mils per hour. I have Theophylline order, 0.7 milligrams per kilogram per hour. The weight is 73.5 kilograms. Available is Theophylline, 800 milligrams in a 500 milliliter bag of D5W. What do you set your mils per hour to on the pump? So again, I need mils per hour. It's the exact same setup. X mLs per hour. What do I have up here with mils per hour? Well, I'm going to take this one because I've got the 500 mils and 800 milligrams. So I just set it up the same way as the last one. Pull that information down. I need to change that milligram out. I'm going to pull out that 0.7 milligrams per kilogram per hour. That way I can cancel these out. And now I just have mils on top and kilogram per hour. So I need to get rid of that kilogram. What do I have up there but kilograms? Weight up there in the weight. That allows me to cancel these kilograms out, leaving mils on top and hours on the bottom. Once I see that that's all that's left, I can stop and I can multiply, cross, and divide. 32.15625. Once again, it's mils per hour, so I round to a whole number of 32 mils per hour. The next one, clindamycin at a rate of 10 milligrams per minute, and what I have is 900 milligrams in 100 mils of normal saline. What do you set the pump to in mils per hour? We've already done 2 of these. But once again, X ml per hour is on the left side. Let's match something. What do I have? Well, I have 900 milligrams in 100 mils. So whatever this is, I want it on top. I'm going to take that, put it right here, 100 mils and 900 milligrams. I need to cancel out the milligrams, and I have 10 milligrams per minute. That allows me to place that there and cancel that. Now I have mils on top and minutes on the bottom. I need that minutes to turn into hours, so I'll put minutes on top with that gold conversion number, 60 minutes in an hour. Canceling it out allows me to have milliliters here and hours on the bottom. There's nothing left, so I just multiply, cross, and divide. 66.6666 becomes 67 mils per hour. Let's get to some bigger ones. A patient with hypertension orders for nitroprusside at 5 mics per kilogram per minute. Your concentration is 200 milligrams and 500 mils, and the patient weighs 200 pounds. How many mils per hour should you set the pump to? Okay. X mLs per hour. I'm just going to start. I already know this ml needs to match here. So 500 mils over 200 milligrams. Good. Do I have anything else in milligrams? Well, I don't, but I have micrograms. So I need to convert to micrograms. 1 milligram is 1,000 micrograms, allowing me to cancel out the milligrams. I don't want micrograms on the bottom. I need hours. So I need to cancel out the microgram. I have 5 mics per kilogram per minute. So I'll put the 5 on top with micrograms for cancellation, leaving the kilograms per minute on the bottom. Okay, now I need to convert and get that kilogram out. Well, how do I do that? There's no kilograms, there's pounds. So I need to convert this kilograms here. By canceling out the kilograms, it's 1 kilogram per 2.2 pounds. Canceling that out. Okay, so I have milliliters on top, minutes and pounds on the bottom. So now I need to take this pounds and cancel that out. How do I do that? I'm going to take the 200 pound patient, 200 pounds, that way I can cancel these out. Now I have milliliters on top and minutes on the bottom. I need to get rid of the minutes. Same conversion as before, 60 minutes per 1 hour. I cancel everything out. Now, after this whole long equation, I literally went step by step so I could see every little area canceled out as we found it. I have mils left and I have hours left. I need mils per hours. Becomes this huge long equation at 68 mils per hour. You want a longer one? That's what I thought you said. Here we go. 1,250 mils to infuse in 7.5 hours. The drop factor of administration is 15 drips per mil. What is the drip rate you're going to set? Drip rates are X GTTs per minute. So what do I have for GTTs? I have GTT per mil. So I'm going to take that and apply it there. I need to cancel out the milliliters. What do I have up here that deals with that? 1,250 milliliters per 7.5 hours. 1,250 mils per 7.5 hours allows me to cancel out the milliliters. Now I have drips on top, hours on the bottom. 1 hour over 60 minutes. So I needed drips per minute. Look at that, that's even shorter than the last one, not longer. It's a quick conversion. Gives us the actual happy cloud of 40 drips per minute. Esmolol, 75 mics per kilo per minute. Weight is 60 kilograms. Esmolol, 5,000 milligrams and 500 mils. We want the pump to be, we want to know how many mils per hour to set the pump to. So, X mLs per hour. I already have this. We know that this ml has to match. We already have it here. So 500 mils over 5,000 milligrams. Nothing up here matches milligrams, but I have micrograms, so I need to convert this to microgram. Canceling that, this is of course your equation, 5,000 milligrams and then 1 milligram on top. Cancel the milligrams. Now I have mils per microgram. I need to pull that microgram out, so I pull up there at 75 mics per kilo per minute and say, okay, I just canceled out the micrograms. Now I have kilograms per minute on the bottom. I need to get rid of kilograms. So I take that patient's weight, 60 kilograms, so I can cancel it out. Now I have minutes on the bottom, 60 minutes per hour. Now all I have is mils on top and hours on the bottom. I multiply across, divide out, it gives me 27 mils per hour. Let's do a couple more. Inacor, 5 micrograms per kilogram per minute. Weight's 165 pounds. You have Inacor, 250 milligrams and 250 mils. What would you set the pumps to in mils per hour? Dimensional analysis, once again, XMLs per hour. We have 250 mils and 250 milligrams, so 250 mils, 250 milligrams. I don't have any milligrams, but I have micrograms, so I need to convert. Take that milligram, convert, cancel it out to get to the micrograms. Now, I have micrograms per kilogram per minute to cancel out the micrograms on the bottom. Now I have kilograms per minute on the bottom. I need to get rid of the kilograms. So I take the conversion factor of 1 kilogram per 2.2 pounds and cancel that out. So all I have now is mils on top, but I have minutes and pounds on the bottom. So let's get rid of those pounds by saying that patient's weight of 165 pounds, dropping out the pounds, and I have minutes on the bottom. So I need to use that 60 minutes per hour to be able to cancel out minutes. Now all I have is mils and hours. Multiply across, then divide to give me 22.5 mils per hour, which rounds to 23 mils per hour. One of the longer ones, but it's a very good practice. Speaking of, you have a dosage calculation book. You need to be using it. There's Pinterest, there's practice of these actual questions. There's multiple online resources to help you get more and more practice. So I want you to keep practicing these. These are some very difficult and long dimensional analysis, but if you follow dimensional analysis, this should help you make sure that you are getting every step of every equation completed. I hope you found this interesting, or at least informative.